Alright guys, in this lab exercise, you're going to be learning how to use the volumetric pipettes. And you're probably wondering, oh no, not again. Especially if you took CTC 114 wet laboratory technique. Because quite honestly, we start the semester out in 114 in the same exact way. But I've already kind of told you why we do this. It's so that all of the new faces that join our program in the spring semester, well, we're not just setting them out to drown, so that way we can nestle them and we can snuggle them and we can baby step them little bits by little bits and get them used to our laboratory before we go further into the quality control realm of this particular class, where everything's going to be new for everybody. So, if you are a 114 returning course, well, guess what, folks? This is really the same exact exercise as what you did before. So, in this lab experiment, if you've not taken 114, you will be using a volumetric pipette. We'll show you how to use the volumetric pipette the proper way, and then we'll show you how to deliver, we'll show you how to dispense, we'll show you how to suck up solutions, and then there's probably going to be a little bit of smidgens of little external YouTube videos for you to watch as well that focus on the proper use of a volumetric pipette. So here on the very first page, you're going to see volumetric pipette pictures as well as just regular standard pipette bulbs. We do have things other than pipette bulbs in our laboratory, but this is where we like for you to start, because there is a chance that some of the labs that you will work for will not have fancy little tools, believe it or not, that our chemical technology laboratory spaces will have. So because of that, we have to show you the basics of the basics, and then later on in the program, we can turn you loose with more of the automated pipette fillers and so forth, and we'll show you how to use those. Volumetric pipettes, folks, this is what they look like. They are a very long piece of glassware. Really comes in all different sizes that you can imagine. Everything from a half a milliliter to 0.1 milliliters all the way up to 100 milliliters or greater. We have a very good assortment of volumetric pipettes in our laboratory spaces, and for the most part, with our volumetric pipettes that we like to use, we go anywhere between 1 and 50 milliliters for volumetric pipette size. And that includes 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10 and 15 and 20 and 25 and then 50. So there's a wide different volumetric pipettes that you will see in our drawers, crammed in every little corner, and probably in your lab drawers as well for you to use today. So, or when you come in to do the lab. So all of these volumetric pipettes, they are made somewhat in a different way. We have what we call a Class A volumetric and a Class B volumetric. Our laboratory spaces really only play with Class A volumetrics. Think of this as like a letter grade for a course. If I have a letter grade of A, I'm the best of the best. I'm the best of the class. You can't get me. I am perfect. Well, that's kind of the Class A volumetrics. They're a little bit more expensive most of the time, unless we can find a sale on them. And the Class A's are more expensive because they're more precise. The Class B actually has 2 times the error on average associated with that particular volumetric pipette, meaning that when I deliver a volume, I'm going to be twice as bad, just automatically straight off the top, because it is a Class B volumetric and not a Class A volumetric. So please keep that in mind when you are working in a laboratory environment. Not all volumetrics are created equally, and if you are in charge of ordering, then you probably need to order the Class A volumetrics, not Class B's, even though they're cheaper. And the reason is Class A will lower the error that you will experience in a laboratory arena. And that's what this class is all about. It's all about quality control. It's minimizing our error. It's making sure that we get legit numbers on our reports, that we feel really good when we provide them to someone. And every step that I can take to minimize my error is always going to be a good thing for quality control. All right, so in the middle, that's the pipette bulb. The pipette bulb, you're going to squeeze up here at the very top first, and that creates something like an air pocket. And then you're going to put the bulb on top of the volumetric. And then the second thing that you're going to do is slowly let go. Let go, Jack, let go. And then when you do that, that solution will suck up into the piece of glass, just like a straw would. If you were sucking up through a straw, liquid goes up in the straw into your mouth. Well, liquid's going to go up into the volumetric in the same way. But we hope that we do not get any liquid. No liquid. Absolutely none. No way, Jose, in the bulb, because that can ruin the bulb if we're not very careful. So before we turn you loose on more expensive tools that you can use for volumetric delivery, we're going to get you old school, because not every lab will have the new little tricks up their sleeve. And then the second reason is because we can't quite trust you yet. And I would rather for you to mess up one of these pipette bulbs than mess up one of our very expensive pipette fillers. So we stay away from those, at least for now, but we do have them because we're technology, right? And we should be focusing the technology spin of the laboratory. We will, I promise we will. Just not right now, not until we trust you. All right, so over here to the right-hand side, these are pipette pumps, and they're just really an alternative to the pipette bulb. That's all that they are. It's just a different way to get it into the volumetric pipette. That's why we use the pipette pumps. Some people prefer the bulbs. They think they're easier. They think they're faster. Other people prefer the pipette pumps. We do have a few of these, but not very many, because we just simply do not like them. But the pipette pumps stick on top of the volumetrics right up here, just like a bulb would. And there's a little thumb dial on this thing, and you just take your thumb and you spin and spin and spin and spin and spin, and that will slowly suck up liquid into the volumetric pipette for you. So that is a thing. You can use those. We're not going to turn you away from those. But if we demonstrate this for you for the first time, you're going to see us use a pipette bulb, not a pipette pump. Most of the videos as well, you will see pipette bulbs, not pipette pumps. But they're cheaper. They're easier to use. If something does go into them, well, we trash them. We throw them away. We get out a new one. And my feelings are not hurt, because they are the cheapest version, I think, of a tool that we can use on a volumetric pipette in order to get that volume delivery to take place. All right, so a couple of terms here. Volumetric pipette is just a piece of lab glassware. It's hollow on the inside. It's going to suck up some liquid on the inside. You can get them to be a very wide range of volumes, and actually we go higher than 25 mils, but 0.1 to 25 is pretty common in a laboratory setting, but they can go much higher than this. I need you to understand that, because they can go higher than 25. These are not, I would say, expensive, but they're not cheap either. So most of the time, depending on the size of these, with our Class A's, we spend anywhere between $15 to $75 per volumetric pipette. So if you break one of these, there goes $15 to $25 or $75 down into the trash can. So handle them with care. Don't tip them. Don't damage them. Just handle them appropriately, like they are a little piece of cherished gold. Because, you start getting neglectant here, and you start slapping these things down onto a countertop, and they start breaking left and right. We're going to easily eat through thousands of dollars of glassware if we are not careful with that. And we do not want to do that, right? Otherwise, I'm going to take your first paycheck when you get a job. It's mine, because I need that money back for all of the volumetric pipettes that you have broken while you've been in our lab. All right, number 2 is pipette bulb. We've talked about this already. It just helps you suck the solution up into the volumetric pipette. Please do not use your mouth. This used to be a thing. Believe it or not, this used to be a thing. Volumetrically, pipetting by mouth is the way that we would pipette solutions back in the day. There are some people that I had as instructors that did this because they didn't know any better. So because of that, they probably accidentally got some vapor up into their mouth or some liquid up into their mouth. It probably didn't feel very good, but this is a safety concern, as you can imagine, and we do not pipette anything by mouth anymore. So acids, bases, aqueous solutions, none of that, folks. We always use a pipette bulb Or number 3, a pipette pump. So this is just semi-automated. It allows me to take my finger, dial it up. Normally they hold the solution in the volumetrics until I'm ready to deliver. And then I'll just take it off or hit the release button, and then it will begin to drain out of the volumetric pipette for me. So if you don't quite know what I'm talking about, there is probably an external video in the playlist that you're going to watch, and that will demonstrate how to use a volumetric pipette the proper way. And I think that once you see that in action, and then once you see us do it for you in person, then I think that you'll feel more comfortable with this type of scenario that we are talking about. Number 4, we also have a graduated pipette. What does that mean? Does that mean it's a little pipette with a degree? And the answer is no, that's not a graduated pipette. Hopefully that will be you by the time you finish the program. You will graduate, and all my little graduation pipettes are going to be walking across the stage getting their degrees. But a graduated pipette is this idea that I've got a very long piece of glassware called a pipette, and graduation means they are tick 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 all the way up. They have little dashes all the way up and down that piece of glassware, and that is a graduated line, which is dividing that piece of glassware most of the time in terms of milliliters. So 1 milliliter, 2 milliliter, 3 milliliter, 4, 5 milliliter, 6 milliliter, 7 milliliter more. All right, so there is kind of the idea of what a graduated pipette is. It's just a series of lines. They are etched on the glass, and it allows you to add multiple volumes, not just one, but multiple ones. Most of the time, in our lab facility, we will see these graduated pipettes that have a tendency to be less than 1 milliliter in total volume. So we've got a 1 milliliter volumetric that's straight up 1 milliliter, nothing else, no other choices. You just get 1 mil and nothing more. But we also have 1 milliliter pipettes that are graduated. And what that means is that you can take it to the top, and absolutely you can deliver 1 milliliter using this. Or you don't have to take it to the top. You can deliver 0.3 mils or 0.5 mils or 0.7 mils. You have a choice of what you want to deliver because there's more than one line that is etched on the volumetrics. These necessarily don't have as good of an accuracy or precision as some of the other volumetrics do. The graduated pipettes tend to deviate a little bit from what we really like to do in a laboratory environment. So because of that, if we can get by with a whole number that a volumetric pipette is made to deliver, that one volume, it's made to deliver that one volume, then that's what we're going to do. We just stay away from the graduated pipettes as much as possible. We just think that your numbers are a little bit worse when you do them. There is something called a serological pipette. This is also called a Moore pipette, and these are pipettes that are graduated, but they're not as accurate. And believe it or not, they actually use quite a few of these in the clinical side of the house. So if I'm working for some type of hospital setting, maybe I'm not working directly with patients, but maybe I'm doing some tests in a laboratory environment, and I need to pipette various solutions and get some tests kind of completed and performed, then serological pipettes can be used for that. They are very similar to volumetrics. They look kind of like volumetrics in a way, but they are not volumetrics. Volumetrics are actually a higher caliber or a higher standard piece of glassware for volume delivery. So with that said, we just don't really have a lot of these. We don't need to go down this rabbit hole because volumetric is where it's going to be at. We need to be as good as what we can be, and volumetric pipettes that are made for one type of volume delivery is going to give us the best numbers possible. All right, here's an in-class problem, and it says, suppose a technician is verifying the accuracy of a volumetric pipette. The technician delivers 5 milliliters of water with a 5 milliliter pipette, and they do that a total of 6 times. She weighs each sample. Now remember, density of water is about 1 gram per mil. Therefore, these samples should weigh about 5 grams. Lie, lie, lie. You're telling me a lie. That's not true. That's not true. That's right. This is not true, folks. In a general chemistry course that maybe you have taken, or a science class maybe in high school that you've taken, they will often instill into you that water's density is 1.00 grams per milliliter. No, it's not. It is close to 1, but it is not 1 exactly. It is a little bit less than 1, believe it or not. So with that said, we are generalizing here. We're trying to make it easy for you. That is why they tell you that in a regular science course, but I need you to keep in mind that these are not exact values. These are just to make it easy for yourself. That's it. So 1 milliliter of water is not 1 gram. It will not be 1 gram. It's actually something a little bit less. But for the sake of the problem, we'll just pretend, okay? So A says, what's the average mass? Oh, okay. Well, that means I need to do some math work. Number B says, what's the standard deviation? Whew, I hope I don't have to do this by hand. Well, if I don't want to do it by hand, what do I need? Excel! That's right. I need to pull up Excel here for a minute. Number C says the volumetric pipette is classified as Class A with a tolerance of plus or minus 0.01 grams or less. Does it pass or does it fail? And D says calculate the error of the analyst if the actual weight should have been 5.000 grams. Again, that's not true, but we're going to, for the sake of the problem, keep it easy, and that's what we're just going to deal with. So let me pull up Excel because it looks like we're going to have it in order to calculate this, these answers to this problem. So I've pulled up Excel over here on the right-hand side of your screen, and I've enlarged the cell so that way you don't have to take out a magnifying glass and look at your computer screen. So I'm just going to click anywhere in Excel. Quite honestly, like we've done before, it doesn't really matter. Just click a cell, and that's where you're going to start data entry. So I'm going to key in the 6 measurements that this example problem is giving me. So 5.0012, 4.9918, 5.0001, 5.0103, 4.9, oh gosh, right, let me get rid of that, 4.9997, and 5.0024. So those are the 6 values, which means that someone has went into the lab, they've used a 5 ml volumetric pipette, they delivered 5 milliliters of water, they've weighed it on a balance, and they've printed off some receipt tickets. So they've brought this back to me, maybe as a QC person or a lab manager or someone to double check their work to make sure they were doing it the proper way. And they're saying, okay, did I do a good job? Okay, well, this is kind of how we do that, or at least a few steps in that direction. So part A says, what is the average mass? So you could, if you want it to be crazy, add them all up and divide by the total number, which is in this case is 6. But why do you want to do that? You've got Excel. All students at Cape Fear get Excel for free. You just got to go into Office 365, download a hard copy onto your desktop. It is free of charge while you're a student, so might as well take advantage of it, right? Or you can use 365 for free, and that will be like a Google Drive where you can save things into your account, and no matter the computer that you are working on, you've got access to those files. Okay, if you want to know more about that, please see your instructor. All right, so here, equal average. So that's kind of the way I need to start out this calculation. Equal, ding, ding. That means Excel. Okay, what do you want me to do? What do you want me to do? All right, so I type in the word average, A-V-E-R-A-G-E. I open the parentheses up and I highlight. So click on your mouse, drag down, highlight the entire column and hit enter. Ta-da! That's all that we got to do, folks. It's as simple as that. So that looks great to me, but the problem is that here my Excel, that's way too many digits after the decimal, right? So it looks like all of my data points that I have here in the example problem are 4 after the decimal. So I want to make sure that I kind of mimic or mirror that. So I'm going to drag this and kind of enlarge this a little bit so that way you can see this happening. And up in your toolbar that you will have in Excel, there is a section called number. That's under the home icon, right? That's where it's going to kind of launch anyway. You don't have to do anything special, but there is a number section and there's arrows that go to the left and there's an arrow that goes to the right with a bunch of zeros after it. So I'm going to click that number and I'm going to tell Excel, I want you to trim this number down. It will round appropriately. And I want you to give me that value on the screen to match the number of decimal points that I have keyed in. So that's going to be 4. So 5.0009. All right. Now, the next part, so part A has now been answered. What's the average mass? And then part B says, what's the standard deviation? All right. So I'm just going to type in AVG right there. So that way I know what that number means. And that way no one really questions it. Like, what's this random number of 5.0009? Well, I now know because I've typed in the abbreviation for average that I like to use, AVG. That's okay. No one says that you can't do that. And now we need to calculate standard deviation. So standard deviation is all about precision. How close are the values together? So I'm going to hit equal, and then I'm going to key in, and Excel is going to go ding, ding. Okay, I need to do a calculation. What do you want me to do? I'm ready. All right, so STDEV, I'm going to key that in. I'm going to open the parentheses up, and that now allows me to click and highlight the set of data that I want it to do a standard deviation of. So I'm going to click and drag, and I'm going to highlight all of that data, and then I'm going to close that parentheses up, and then I'm going to hit enter. Ta-da! That's as easy as it is, standard deviation. And you're looking at this number and you're going to go 0.00. That's a small number. I did so good with standard deviation. Yay! All my data is really close together. Well, we're going to talk about that in just a minute, but I need to trim this number down. So keep in mind, 4 digits after the decimal, 4 after the decimal, 4 after the decimal, average, 4 after the decimal, standard deviation, probably 4 after the decimal. So I'm going to trim that down a little bit. There we go. And I'm going to write in STDEV. Whee! All right. So there's standard deviation. So that now answers part B. What is the standard deviation of the set of data? C says the volumetric pipette is classified as class A with a tolerance of plus or minus 0.01. Do you pass or do you fail? All right, so 0.01, that is the catch, meaning that if I'm using this the proper way, that piece of glassware should be giving me plus or minus 0.01 from the actual true legit data. So when I do this for real, and when I record my masses, and when I do the average, and I do the standard deviation, what I'm going to be looking for is the standard deviation. And that standard deviation is going to give me an idea of the repetitiveness of my technique. What did I do? How did I do it? And did I do the same thing over and over and over? So this is almost a little bit like error in a way, even though it's kind of not, but it gives me an idea of how I'm fluctuating. So this particular line item says, you should be getting this value, and it should be delivering within plus or minus 0.01 from where it needs to be. So I look at two things here. I'll look at my average and I'll look at my standard deviation. So if I look at part D, it says calculate the error, and the tolerance should be plus or minus 0.01 grams or less. All right, so if my actual true data is 5.0000 grams, and that is what it actually should be, even though it's a lot. That's not true, right? So we know, okay, well, sake of the problem, okay, we'll just say it's 5. And then it looks like here I've got a 5.0009 gram that I did with me, right? So this is actually, I'm going to take that back. This is actually the actual number that I obtained in the lab, and 5 is going to be called the theory number. So this is what it should be, right? So based on what we've told you, even though it's a we're saying theory should be 5 grams. So that 5 grams is great. That's the target. That's what we need to be after. That's the theoretical value. I get a 5.0009 when I actually do it myself. All right, so in order to calculate an error, I'm going to take the actual and the theory, and I'm going to subtract them. All right, so this is the difference. How far away am I from the real, true, legit value? So that's going to be a difference. And then I'm going to divide it by the theory. I'm going to divide it by the number that it should be, because this is the accepted one. I want to know how close I am to that accepted value. How good did I do? That is what this is all about. And then I'm going to multiply by 100, because the question says what is the percent, right? So percent error is what we're calculating here. All right, so in order for me to do that, I can use Excel to do that for me. It's not a big deal. So I can say, all right, listen, I want 5.0009 minus 5.0000, and I'm going to close the parentheses up. I need to do that first, order of operations, give me that subtraction, give me that difference, and then I'm going to divide by 5. If you want to put in 0.0000, that's fine, that's great. It's not going to change your numbers, I promise. And then we can multiply by 100 to get a percent error. So that is a 0.018% error. All right, so calculate the error if the analyst... if it's 5 grams based on the analyst's data. So this is 0.018% error. That's what this is. Now, the question said just calculate the error. So if I calculate the error, because it didn't say percent, then what's going to happen is that I am just going to take these two numbers and I'm just going to subtract them. Okay, this is my value, and then I'm going to subtract the theory value from it. And this can be the error that's associated with the calculation. But very often, we like to take error to the next step, and that next step is percent error. I want to know, like comparing apples to apples. Like this is just a random number. It just tells me how far off I am from the actual true legit thing. So if that's how far off I am, is that really good or is that bad? I mean, that looks like a really low number. Is it a low number? Well, the only way that we can do that is through percentages most of the time. So we take our error and we calculate a percent error based off of that number. So this particular example problem asked for the error, and that would be the appropriate answer. But if this example problem asked for percent error, then it's 0.018. And again, the way that I calculate that, I take the difference, just like I do when I calculate straight up error, and then I'm going to divide by the theory and then multiply by 100 to change it into percent. As far as tolerance goes, a lot of the tolerance is really kind of related to standard deviation. It looks like my standard deviation is within the realm of the tolerance limit that this volumetric pipette should be delivering. So my standard deviation is lower than 0.01. It looks like my tolerance is pretty good. I can tolerate this set of data. I can tolerate kind of giving this to someone and being like, here you go. Is that great? Is that good? And then hopefully they'll give me a pat on the back and they say, yep, great job, good for you. All right, so there's the example problem. Part A, it's going to ask you to deliver a couple of different volumes. So 5 milliliters, 10 milliliters, and then we're going to do that again with 25. And then using a graduated volumetric pipette, we are going to deliver 0.7 mils. I would say see instructor here. And the reason is because we've got different graduated pipettes in our laboratory. And depending on which one you pick up, we might have to deliver in a different way. So I'm going to say when you get to that particular part, that is a very extremely tiny amount of volume that you need to be delivering. And depending on which one you grab out of our drawer, you could have to handle it in a different way. So please come and see us when you get to this step, and we will give you insight of how to deliver using a graduated pipette properly. I actually like to work backward, and that's probably not what you should be doing. But I think that in the beginning, for you to get used to the graduated pipettes, it's going to be easier for you. Otherwise, you're going to have to stop the volume delivery midstream, and hopefully you'll stop it at the appropriate time. If not, your complete delivery is incorrect. So I just kind of like to handle this in a different way, especially if it's the first time seeing the volumetric pipettes. All right. Next up, we like for you to check your data with the instructor. So when you start generating these masses, because you're going to be delivering 5 mils of liquid, you're going to be weighing them, you're going to record that a couple of different times, and you're going to give that to an instructor. When you do that, allow them to check your lab data. Make sure that it looks really good. Make sure that you're delivering the appropriate amount like you should be. And then if you get the all clear, move on to part B. For part B, you're going to see a table down here at the very bottom, and this table is going to be a mix of water, and it's going to be a mix of what we call a stock solution. This stock solution will be blue in color. So what we're asking you to do is take a series of test tubes. That's going to be the easiest, to be honest with you. And when you take the series of test tubes, in the first one, you're going to deliver 10 milliliters of blue solution, and then 7.5 mils of blue solution, 4 mils of blue, 2.4 mils of blue, and then 1 mil of blue. So that way you can do that all the way through, get your blue solutions ready, and then work on the water side. That's kind of how I like to do this. I like to focus on one ingredient at a time, make sure I add that ingredient, the appropriate amount, into each one of those tubes, and then go back and then add my water. So on the first tube, there's 0 water that goes into the first one. I don't need to do anything with that at all. That one's now complete. But on the other ones, I need to add some water. So 2.5 milliliters, add water, 6 milliliters, add water, 7.6 milliliters, add water, and 9 milliliters, add water. If you add these volumes up, what you're going to see is that they all total a 10 milliliter volume, every single one of them. We need everything to stay consistent, and that's why we're doing that, okay? So once you get all of these taken care of, this is going to require multiple pipettes. It's going to require maybe some graduated pipettes as well, especially for your 0.5s and your 0.4s and, you know, these 0.6s that you need to deliver. Those are going to require the graduated volumetric pipettes for you. So once you get all these done, mix them really well, and then once again, bring them to an instructor. So what we're going to do is we're going to use an instrument called a UV vis spectrometer. We're going to analyze these samples that you have prepared, and we want to make sure that you prepared them the proper way. So we hope that the graph that happens on our computer screen is going to be linear. If it's linear, then that is wonderful news. Great job for you. All right. So that is our volumetric pipette lab. You're going to see a data sheet for you to record some of your numbers on. We do encourage you to print off receipt tickets for quality control purposes. So if the receipt printers are working on our balances, absolutely print those off, get them ready, staple them to your data sheet so that way we know that you did not lie about your mass measurements that you wrote down. Next up, you're going to have a spreadsheet, and that spreadsheet is going to be involved in Canvas. You're going to see it do a very similar thing that the example problem did. You're going to take your data that you've generated in the lab, and you'll calculate an average, and you'll calculate a standard deviation for each one of those data sets. So with that said, good luck with the lab. It's not very difficult. It's just get you in the habit of things again. Maybe this is the first time using it. If so, this is your training seminar. And then if you have used these before, that is great, but this is going to be a refresher for you to make sure you didn't get lucky the first time through that you did the lab. All right, so we will see you in the lab, and we'll provide the help when you need it. Just reach out, let us know. But we will definitely demonstrate a volume delivery the proper way for you the first time that we show you a volumetric. Okay? All right, so if you got